Hey, it's Caleb. If you like this video, be sure to subscribe. Hey, what's up everybody? In the last couple of videos, we've talked about all of the characteristics of keys in general. We talked about the word key. In databasing, keys are the key to success. Anyways, this video we're going to be talking about specific kind of keys. Because all of the last videos were kind of concepts, but now we're going to be talking how do we actually implement that into a database. I understand that we want keys and we want references from table to table and we want it all to be connected, but how do I do that? Well, the main two types of keys that you're going to hear are known as primary and foreign. And actually, we're not going to be talking about these two kinds of keys in this video. Surprise! We're going to be going a little bit broad, a little bit more broad. So when you're like a beginner and you're learning database design, you'll probably learn that these are the two kinds of keys. When you want to learn more advanced database design, you'll learn about different categories of keys. So before we get into these two, which if you guys haven't heard of those, just hold up. If you have heard of those, keep holding up. We're going to be learning about what's known as a superkey. Now, for some reason, I think this is one word with no space, and I don't know why there's no space there. So if someone knows, if like one of you guys watching know, let me know, because I really want to know. It's driving me crazy. The other one that we're going to be learning is candidate key. Alright. So before we learn about the candidate key, let's just focus on the superkey. So I'm just going to erase this. Okay. So what is a superkey? Well, a superkey is any number of columns that forces every row to be unique. Now, if for some reason your table is structured to where you can't have every single row be unique, you need to consider adding some kind of column to enforce uniqueness, such as an ID, or you need to make sure that everyone using the database understands how that table works if it's a special case. But generally, every table you will be able to make unique. Now, when you work with databases, you'll often see IDs, so like user ID. This is a type of key. Then you also will sometimes find keys such as like username. The difference between these is that this one's kind of just made up for the sake of the database. User ID of 748. What does that mean? Absolutely nothing. It's just a number. Username actually has some real-world connection. We'll be getting into the difference between these in an upcoming video and which one will be best to use for which situations. But as for now, we'll just be using kind of natural, practical columns that are already in the database rather than IDs. But the same thing can apply with just like an ID field or a column. So let's learn about the superkey. Superkey. It's like Superman, but it's a key. Just like a giant key that just goes and breaks through doors. It doesn't even use the handle, it just breaks through doors. Anyways, let's learn. Okay, let's say we have a table here. Big table, right? Now I'm going to put some columns in this table. That is not straight enough for me. Close enough. Now it just looks worse. Whatever. Let's say we have a user table, just because I always think that's the absolute easiest thing to use. And we're going to have a username, email, password, then we're going to have first name, middle name, last name, and then we'll have birth date. So every single row within this table is going to need a value for each one of these columns. I know this is really bad handwriting, but it doesn't really matter how it looks, just understand the concept. There, now it looks a lot better, I know. You're welcome. Now you can actually understand what's going on. Okay. Some instances for databases, you will allow people to put in blank values. So for example, if someone doesn't have an email, for example, we could make it optional. That way some people have null or no value at all, other people have values. But for this case, I'm going to say everything is required because let's say you use your email to sign in or to verify your account. Dang it, I always drop my chalk. How do we make sure that every single row is talking about one entity and every single entity only has one row? Everything is unique. If we have a person, I'll draw a little guy over here, right? And he wants to sign up for this website, so he goes to this website, here's this website, he puts his information in, and that information goes into a table, right? He probably won't actually have access to the SQL, because if just some random user on your website has access to your database, kind of got some security problems. But anyways, what's going to happen is he will be entered into this, and all of his values will be put into these value spots. So we have a username, make it CC, email, cc@blah-blah-blah.com, pass is pi, first name is Caleb, middle name Daniel, last name Curry, birth date 02/13/90. So this guy inserted all that information within this database. And if you can't read it, doesn't really matter. Now, when another guy comes, or let's say a gal, so this lady comes and she's all like, oh, I want to sign up for this website. So she signs up for this website. And she puts her information in. And this also goes in the database as a new row. So this is just the column headers. This is separate from the actual data. The rows, though, they have individual values. She can put her values in. I'm not going to write them all out because you guys get the point. How do we know that each individual row is unique and that talks about one individual entity, in this case a user? Typically whatever the entity is what the table is titled, so the entity would be the user. How do we know that every single row is talking about only one user, and every user only has one row, the rule of one? We don't want Caleb to be able to come in here, create a new account, and make his username CC and all the same stuff again. Now in some instances we may be able to allow them to make more than one account, like I could make an extra YouTube account if I really wanted to. That would be okay, so I could have the same, a different username, a different email, same password, same first name, same middle name, same last name, and the same birth date. The only thing that changed is a username and email. Now, what the table is trying to define has kind of changed. We're no longer trying to define the person, we're trying to define the user account. Because now there's two accounts and then they're completely separate entities. Hopefully that kind of makes sense. But you don't really need to worry about all those specifics. I'm getting completely off topic. So what were we talking about 10 minutes ago? I think we were talking about superkeys. It's any number of columns that forces every single row to be unique. If you take all of this information and compare it with another, let's create a new row. Let's say this lady here actually ended up putting her information in. Her username is A, her email is B, password C, first name is Hi, middle name is Yo, and her last name is Hello, and she was born 03/16/72. That is her birth date. Well, now, if you compare these values, they're different. Not every single individual value has to be different. For example, this girl's last name could be Curry, and that'd be perfectly okay. But all of the values as a whole have to be different. So if, for example, someone came in here and put all of this information up here, down here, CC at blah blah blah, pi, Caleb, Daniel, Curry, 02/13/90, that is not a unique row and it would cause an error. So the super key could be all of these columns right here. Now, superkeys are usually not defined within the database. That's because they're so broad. You have all this information, of course it's going to be unique, simply because you can only use a username one time. Typically the email is only one time. So if someone comes down here and tries the username CC, well then you already got an error, it's not going to work. So all this extra columns right here, kind of unnecessary, because we could simply do that same thing with just the username. So a superkey is any number of columns that creates a unique rows. A candidate key is the least number of columns. Where did I write that? Can you see down here? Yeah, okay, we're good. So a candidate, I'll explain why it's called a candidate in a second, or in the next video or something. A candidate key is the least number of columns. So for this example, we're not going to allow two people to have the same username. We may allow them to have the same email. We may allow them to have the same password, first name, middle name, last name, and birthday, but not the same username. Because then how do you tell them apart? You can't, because all of their information is the same. They're exact clones to the database. And we do not ever want that within our database, typically. I can't really think of any examples where you would want duplicate data. But okay, anyways, the candidate key is the least number of columns needed to force every row to be unique. In this example, the username is enough to make it unique. So we can take the candidate key and have it to be just the username, or I guess we could circle the column, because all throughout the rows are going to be unique. So the candidate is least, and superkey is any. Alright, now when it comes to database programming, let me clear this up so your brain doesn't explode anymore. It takes forever. I'm on a time limit here, guys. People are going to stop watching. Alright. Now that I just got my chalkboard to listen to me and erase the stuff. When we're talking about database programming, there's not really a time where we're ever going to tell your database that this is a superkey, because superkeys are not practical. They are for designing your database only. When I looked at that column, first thing I do is I think, superkey, yes, every single row can be unique. That's the first check. So you ask, can each row be unique? That's the question. That's to define, that's what the superkey is questioning. Can each row be unique? And even better word, can every row be unique? Because every single row within a table has to be unique. That's what the superkey is asking. Once we figure that out, if it can be unique, then we move on to figuring out the candidate key. So now we ask, how many columns are needed? Can you read that? Hopefully. So the first question, can every row be unique? Yes, that means we have a superkey. That's all we have to worry about. We don't have to figure out which columns or anything like that. Can every row be unique? Always. Think about all the possible values. Is it possible for a duplicate? If it is, you got to figure something out. If it's not, you're good. So every row can be unique? Yes. Check. Move on. How many columns are needed? Now you figure out the least number of columns needed in order to create unlimited uniqueness forever. So no possibility of uniqueness. And we are allowed to put some kind of like limitations. We can put a unique, we can use the word, it might be different for different relational databases, but if we use a unique index, for example, every single value within a column has to be unique, and that's a requirement for people to put in. So if it's not unique, we give it an error. That's how we force values to be unique. So how many columns are needed? Once we figure that out, we have what's known as a candidate key. So in the last example, it was just one because we could use the username. Now, the next thing I like to figure out is how many candidate keys do I have? I'm just going to use CK for candidate keys. How many CK do I have? What does this mean? Well, we can actually have more than one candidate key. In the last example, we had a username. We also had an email. Okay? Well, email could also work as a candidate key because you could put a requirement that every account has a unique email. Some websites are cool with people using the same email more than once. Some websites aren't. Usually they're not. So there might be a chance where we have more than one candidate key. Or if rather than using the username, you want to use something else, you could have it to where we could have, let's say you can use your email more than once, we could have first name plus last name plus middle name, or middle initial. So that eliminates most possibilities of uniqueness. But there's still a possibility that people have the same name. So then you add birthday. So now you have to find someone with the same first name, last name, middle name, and the birthday. Very rare, still possible. So then we could add a third, I guess 1, 2, 3, a fifth column. We could make it email. Or we could do something such as address. Alright, let's go with address. This could be a candidate key because we have first name, last name, middle name, birthday, and address. They all have to be unique as a whole. What are the chances of a person living at a certain location, born on a certain day? Also, what are the chances of two people having the same name, same birthday, and living at the same place? Unless you had twins and you named them the same thing, and if that's the case, shame on you. I'm just going to confuse people. That could be a candidate key. Now, is it the best candidate key? Probably not, because we're using 5 columns, and it's still technically possible to have a duplicate, but very, very, very rare. Alright, so how many candidate keys do I have? You figure them out. I like to write out the possible candidate keys, and then we move on to the next step, which is defining the key that we will use for our table. Once we have the candidate keys, we can choose one of them. They're called candidate because there's an options. Like you could have your first candidate key. You could have candidate key 1, you could have candidate key 2, and then you could have candidate key 3. This could be the username. This could be the email. This could be that long first name, last name, password, blah, blah, blah. Or whatever you really want it to be. Now, you have to decide which one will be your primary key, which is what we'll be talking about in an upcoming video. So be sure to stick with this series. Sorry this video was super long, man. These videos are just getting long. I'm not sure if I should cut them in half or just continue talking about subjects. So let me know what you guys think. If I should split videos up into shorter pieces, or I could have broke this up into Superkey and then candidate key, or if I should talk about big concepts like this, because this video is almost 20 minutes long. So yeah, thank you all for watching, and I'm hoping that this video was helpful. If not, or if you're confused about anything, just leave me a comment and I'll be sure to try to help you. Thank you, and subscribe.